Model maintenance. We've been leading up to this tutorial in the previous two where we talked about how models deteriorate and why they deteriorate. And today it's time to understand what we can do to prevent them from deteriorating, or at least find out that they're deteriorating on time to replace them. And I'm going to cut straight to the chase here. This is the process that I'm going to be talking about. It's called the ARR process. That is my own abbreviation, ARR, and we're going to go through every single one of these letters one by one. And the way this process works is it's a hierarchical process. So first you do the first letter, A. If that works, then you're good. If that fails, then you move on to the next letter, R. If that works, then you're all sweet. If that fails, then you move on to the last step, the last R. So let's find out what they are. A. A stands for assess. This is by far the most important part of the model maintenance cycle. You have to look at your models. Periodically, you have to assess them and see how they're going. You can't just leave them alone and hope for the best or wait until they tell you that they're not working, because that's not going to happen. You have to take your models and once in a while run a fresh sample through them. And for one that you already know the outcome, say take another 1,000 people randomly selected from your bank, or 1,000 toothbrushes sampled, or a couple thousand, and see what happened there. Like, you already know the outcome. You already know whether or not those people left, whether or not those toothbrushes were faulty, and but run the data through your model and see what it would have predicted. Create the cap curve, check the rule of thumb, see how much worse it is than the original model that you created, and determine for yourself, are you happy with that or not. If you're happy with that, great. Your model's doing fine. Let it keep running. If you're not, you got to move on to the next letter. Next letter is R for retrain. So this is the point where you're not happy with how your model is performing. It's the cap curve is flattening out, and you got to do something about it. So retrain implies keeping the variables that you've already selected. So in retrain, you don't have to do that whole process that we went through. You don't have to throw everything, take all the variables that you have in your company, throw them at the models. Obviously select them logically, but then still throw them at your model, and then do the backward elimination process, and then find out the coefficients. You don't have to do all of that. In retrain, you keep the variables that you've already found out. Like, for instance, we decided we'll keep the dummy variable called Germany. We'll keep the dummy variable for gender. We'll even keep tenure, but we'll exclude other things from our model. And all you have to do, since you're keeping the variables, you just have to give your model a fresh sample to train it on. So what will change is the coefficients. The coefficients of your logistic regression will change because you've given your model a fresh sample. Of course, you'll have to have training data and test data, just like we did. And once you've used the training data, then you check your model on the test data. And if the cap curve improves, then from there you deploy the new model, or the refreshed, retrained model. That's what it's called, retrained model. You deploy the retrained model, and maybe you monitor for it for a bit, a bit more frequently. So instead of, if you are monitoring your models once every 6 months, this one you might check up on it in 2 months, and then in 2 months again, and then 2 months again, because it is kind of on probation. It's a new thing. You've retrained the model, but that might fix the situation. That might be sufficient, and that might happen when your variables are still explaining what's going on. It's just that the coefficients are not sufficient. For instance, let's say age is a important factor, and also tenure is an important factor, right? But in our model, age was way more important than tenure. But let's say that over time things change, and they're still both important, just that tenure has become a bit more important, or much more important. And now the coefficient for tenure has to be greater, but your model hasn't had a chance to understand that. You have to give it some fresh data and train it on that, and maybe that it'll pick that up, and maybe it'll start working well from there. So if that gives you a cap curve that you're satisfied with, then perfect. Keep that model and continue going down that path. But if that fails, then you have to move on to the last R, which is rebuild. You have to rebuild your model from scratch. And we're talking about everything. Completely scrap the model that you have. Or if it's not doing that bad, if this is like a preliminary phase, and we'll talk about this in a second, then don't scrap it completely. But basically what you have to do is go all the way back, find the variables, do this whole process again, and get a new model. Now, speaking of this whole scrapping business, sometimes if your model is performing really poorly or it's rubbish, then of course you have to scrap it and build a new one. But if you're doing this model maintenance process right, then you'll pick up the fact that it's deteriorating on time. You'll pick it up early. And it's not, the model's not working poorly yet. It's still doing a good job, but you just want to see if you can do a better job with a new model. So in that case, once you build the second model, you run them side by side. And this is called a champion challenger setup, where your existing model is the champion and your new model is the challenger. And you're running them side by side, and you want to see which one performs better over time and basically in real life situations, and then you'll keep the one that's performing better. And you can do this in different ways. You could run the champion challenger and only use the output of the champion, or only use the output of the challenger, but just monitor them at the same time. Or you could actually split your population in half and run half through the champion, half through the challenger. It's up to you how you set this up, but that is a good, valid approach to make sure that if you are going to replace your model, that you're not replacing it with something that's actually worse. And that's basically how you do model maintenance. Remember to do it on time. sounds like a car maintenance, right? Don't forget to do your car maintenance. But it is a fair point. You should do your model maintenance on time. You should schedule it. Frequency depends on the industry, depends on what exactly it is you're modeling. It can vary. It can be 3 months, 6 months, 12 months, 2 years. But I would actually, that is the frequency of when you need to update the models. I would actually assess them at least every 6 months. So at least once 6 months, you go ahead and just quickly assess your model. It doesn't take that long. And then maybe if things are changing quickly, or you're in a very fast-paced environment, a business environment, then maybe assess your models once every 3 months or so. Too frequent is also, there's no point in that. So assessing a model every day is definitely doesn't have a point. But you will gauge over time what is the right frequency for your environment and for your specific models. Just don't forget to do it, because it's really sad when somebody deploys a model and it deteriorates over time and nobody picks it up on time to fix that or replace the model. Now make sure to check out these videos on the right or the full course in the description to continue your learning, and I look forward to seeing you there.